Welcome back for one more conversation on quadrilaterals. We want to take a look at some alternate definitions, which is just another activity for us. So again, I'll start off by completing a couple of these, and then I'll allow you guys to finish the remainder of them. So for this activity, what we want to do is we want to take a look at the given property. So the first property is the diagonals are perpendicular bisectors of each other. And we want to say, all right, if we have that particular property, which of the quadrilaterals are we talking about? And if it isn't actually specific to any one quadrilateral, we would simply say quadrilateral to be, hey, look, it's not any specific one. All of them could have this property. So some of these properties might already appear in the first activity that we did, the computer activity. And you are welcome to reference that, as well as the definitions that we also looked at to help out with this. So what I'd like to do is that actually I'd like us to take a look at just the first two properties, and we'll talk about those. But I want to look at them in the opposite order. I'm going to look at the second property, and then I'm going to look at the first, because the first property is a refinement of the second. All right, so the second property is the diagonals are perpendicular to each other. So I'm going to actually go back up here all the way to the top and remind us that when we're talking about diagonals, we're talking about the lines that go from one corner to another. So those would be the diagonals here. These would be the diagonals. Here, these would be the diagonals. Okay. So we want to talk about when the diagonals are perpendicular to each other. That's the second property. But to help us out with that, right, I want to take a look at this program again, just because it's helpful. And so I'm looking at one property. I want to look at all of our quadrilaterals. If I have the property that the diagonals are perpendicular, essentially what ones do I know that I'm talking about? Well, it looks like I'm not necessarily talking about a parallelogram because I don't have that they're perpendicular. I do have that a square, if I were to draw the diagonals, they would be perpendicular. Kite, if I drew the line from P to N and O to M, I would have perpendicular bisectors. But if we are careful here, we'll notice that we can create a square when we're looking at a kite. All right, so we can also take a look at a trapezoid. Now, on a trapezoid, we want to be very careful because it actually works out that we could accidentally, well, not necessarily. I was thinking we could accidentally end up with a parallelogram or a square, but they're very careful here to make sure that we're not doing that. So that's excellent. So could we end up with perpendicular diagonals? I'm not certain that we could. We might be able to come really close, but it wouldn't necessarily be true. All right, what about an isosceles trapezoid? It appears no would have to be my guess in this case. Isosceles trapezoid. Interesting. All right, and then of course a rectangle, there are some cases in which we can. And then we also have, all right, so finally we also have a rhombus that we could consider. And we actually have that these diagonals do appear that they're going to be perpendicular to each other all of the time as well. So in this case, they could be perpendicular. Here they could be perpendicular. And here they always will be. So we have that it's a kite and a rhombus. Both kite and rhombus would give us this scenario. So there's a couple of options here. Really, it looks like if we have this particular property, what are we guaranteed, right? What are we guaranteed to have? Well, we could actually find perpendicular bisectors on a lot of them, but we're not necessarily guaranteed to have any. So all that we're guaranteed is to have a quadrilateral. There were many different ones that it was true for all the time, but there were some of them that, or almost essentially all of them, that they could have perpendicular diagonals. So that doesn't help us out. If we see this particular characteristic, it doesn't guarantee anything, right? Rhombus will always have it, kite will always have it, square will always have it, parallelogram could have it, rectangle could have it, trapezoid I'm not too sure about, an isosceles trapezoid I'm not too sure about. But for the remaining of them, they could have it. So if we have that property, do we know which one it is? No, because there are several that it could be. So we would simply say that we know it's going to be a quadrilateral, but that's about it. All right. Or as far as the quadrilaterals go, it could be any of them. So then a little bit of refinement here. The diagonals are perpendicular bisectors of each other. Well, here, if we have that, if we have perpendicular bisector, if we try very carefully here with the parallelogram, if we change it so that way it looks like they have perpendicular bisector, square, change it a little bit, perpendicular bisector. Here, if we change the kite to have a perpendicular bisector, that looks about right. If we have a perpendicular bisector, which can happen in all four of these cases, because it'll always be true on a rhombus, this, the diagonals are perpendicular bisectors. If we have the diagonals, right, draw them, going to bisect each other, diagonals bisect, diagonals bisect, diagonals bisect. What do we have in each case? Well, in each case, we have a rhombus. They all look like the rhombus does. So we will always have a rhombus when we have perpendicular bisectors, right? The diagonals are perpendicular bisectors. So in this case, this would actually be a rhombus. Because if we have perpendicular bisectors, anytime we manipulated the others to have this quality, what we ended up with each time was a rhombus. So I'd like you to fill in the rest of this. Investigating these properties. Some of them might be a little bit obvious, some of them not so much. Play with those objects in GeoGebra as you feel necessary. But as far as the rhombus goes, rhombus will make an appearance 3 times. So this is including rhombus and quadrilateral here. So rhombus will appear 2 more times. Quadrilateral will appear 4 times, so 3 more times than we already have here. Kite will appear twice. Parallelogram will appear 4 times. Rectangle will appear once. Square will appear once. Trapezoid does not appear, and isosceles trapezoid does not appear. So now you know how many of these things you should have to help you assess whether you've got the correct answers or not. So this is just an aid in helping you identify if you are unsure. It shouldn't be a puzzle for you to fill in with the correct number. All right. So the next thing I want to do is I want to take a look at a Venn diagram that kind of relates all of our 7 quadrilaterals to one another. But I would encourage you to pause this video and complete the previous activity before you watch me create the Venn diagram, because that might assist or help in understanding how our Venn diagram is created, trying to understand and investigate the relationships between our various quadrilaterals. So I'll see you back in a minute. All right, so now that you guys are back, assuming that you did in fact pause, let's go ahead and take a look at a Venn diagram of our quadrilaterals. So when we look at a Venn diagram, the first thing we do is draw the space within which we are working. So the space that we're working in is quadrilaterals. So this rectangle represents all quadrilaterals. Within it are all of them. All right, so of our quadrilaterals, we have a few shapes that are most common. And the first thing to observe is that we have parallelograms, which have two pairs of parallel opposite sides. And then we also have trapezoids, which have exactly one pair of parallel opposite sides. So there's no overlap between the two, because trapezoids have one pair of parallel sides. Parallelograms have two pairs of parallel sides. Of course, isosceles trapezoids are trapezoids. So isosceles trapezoids are a subset of, or would fit within, all trapezoids. That one is pretty easy to identify. The next one that's fairly easy to identify is the collection of rectangles. Rectangles are parallelograms in which the four interior angles are right angles. But we have another thing that's like that too, which is squares. But squares are a rhombical rectangle, if you remember correctly. So we've got a little bit more going on there. So if we draw an oval here, like this, actually let's draw it a little bit larger so it's easier to write within. Pick up more of the rectangle and more of the parallelogram. What we actually have are kites, which don't necessarily have parallel opposite sides, right? They're not necessarily parallelograms, but they could be. In fact, we saw earlier that we could manipulate a kite into a rhombus. And so a parallelogram that is a kite would be a rhombus. And then a rhombical rectangle would be a square. So this is the relationship. A kite, which is a rhombus, and a rectangle is a square. So a square is many things. A square is a rectangle, it is a rhombus, it is a kite, it is a parallelogram. Very interesting. All right. So this is the relationship between our 7 main quadrilaterals. Excellent. If you guys have any questions, would like to discuss anything, or just want to chat, feel free to stop by during my office hours, set up an appointment with me, or send me an email. But whichever the case is, I look forward to seeing you guys again soon in section 5. Have yourselves a wonderful day.